All right, guys, so on Schoology, you will find the homework, days 2 and 3 homework, in the optimization folder. So I'm going to try to do a couple of these for you. We talked a lot about the box problem on Monday, so I feel pretty good about those, but I did not talk at all about things like the fencing. So I'm going to try to make a screen sketch of that and hopefully be able to do this for you. Okay, so Jake has 200 feet of fencing to enclose 2 rectangular fields to create a large enclosing with fencing down the middle and find the maximum combined area. So the first thing that you need to do is do 2 equations, one for area and one for perimeter. Okay, and when I'm looking at this, the area equation, the length is 2x and the height is y. So for this specific fence, my area will be 2x plus y. When I think about the perimeter, I need to also include the fence down the middle, so I should have 4x's and 3y's. So perimeter 4x plus 3y. As I read through, I know that I have something. He wants to enclose the fence. He has 200 feet of fencing. So that is actually my perimeter because that is how much fencing I have. Okay, so you're going to make 2 equations. Okay, then you are going to use substitution. And what I mean by that is take this equation, the one with the unknown, which was area, and solve for either x or y. So I'm going to say that y equals area. I'm sorry, I completely did that wrong. I need to use the one where I have information. So I'm going to solve for either x or y in this equation because I only have 2 variables, not the one with 3 variables. So 200 minus 4x equals 3y, and then I'm going to divide by 3. So I get 200 minus 4x over 3 equals y. And then using substitution, I'm going to take this and I'm going to plug it in back up here. So I know I'm kind of all over the place with my work. So area equals 2 times x, and my y is 200. That's supposed to be a minus. 200 minus 4x divided by 3. And this is what I'm going to type into Desmos right now, knowing that I'm typing in an area function. So what I'm going to get out is going to be x comma a, technically, where x is my part of my perimeter or my area. It's part of my fence, and a is the area of my fence. So I'm going to go to Desmos now, and I might have to close this to do that. Yeah, I think I have to close it to do it. So let's remember 2x and then 200 minus 4x over 3. So if I go to my Desmos, I had my area function was 2x, and then my y was 200 minus, 200 minus 4x divided by, well, that's not what I want to do. I'm going to have to put another parenthesis in here. There we go, divided by 3. And that was my equation. Remember, this was my area equation. So I want to find a maximum. So I'm just going to zoom out until I find it. And 25 then is going to be my x, and then 1,666 and 2/3, or 0.7, is going to be my volume. So if I can go back to my, I don't know that I can go back to my screen sketch. Nope. So we'll go back to our thing here and back to our. We had our equations. A equals 2xy. 200 was our perimeter, equals 4x plus 3y. And then I solved and plugged in, and my thing gave me x comma y. So my x was 25. my area was 166.7. So what needs to happen now is it asks for the maximum combined area. The answer to this is the 1666.7. And if I asked you the dimensions, you would plug in 25 here. And let's see, that would be 100. So these would each be 50. So 50 by 50 would actually be my dimensions.